December 14, 1944, Kummersdorf Proving Ground, 25 kilometers south of Berlin. Hauptmann Friedrich Weber stood in the frost-covered testing bay, watching a newly arrived wooden crate being pried open by two ordnance technicians. The sharp crack of breaking timber echoed across the snow-dusted range. Inside, wrapped in oiled canvas, lay 6 American rifles, their dark walnut stocks and blued steel barrels gleaming in the pale winter light. Weber had spent 12 years at Krupp works before the war, designing artillery recoil mechanisms that required tolerances measured in hundredths of millimeters. He understood precision. He understood German engineering philosophy. What he did not understand was why Berlin had ordered an immediate evaluation of this particular American infantry rifle with such urgent priority. The Third Reich was collapsing. Soviet armies were massing 80 kilometers to the east. American forces pressed from the west. Yet here he stood, assigned to test a rifle that Germany's intelligence services had dismissed as simplistic, crude, unsophisticated. The rifle bore the designation United States Rifle Caliber .30 M1. American soldiers called it the Garand, after its Canadian-born designer. Wehrmacht ordnance had catalogued it as Selbstladegewehr 251A. Self-loading rifle, American. The classification suggested nothing remarkable. German forces had captured thousands of American rifles across multiple fronts. Most sat in storage, unremarkable trophies of battlefield victories that now felt distant and hollow. But something had changed. Reports from the Western Front told disturbing stories. American infantry units consistently outshot German forces in firefights. Wehrmacht commanders reported their soldiers being overwhelmed by volumes of rifle fire that seemed impossible from the numbers of men engaged. Casualties among German riflemen had reached levels that tactical doctrine could not explain. The High Command wanted answers. They wanted to know if this American rifle explained the firepower disparity that was costing German lives in quantities Berlin could no longer sustain. Weber lifted one of the Garands from its crate. The weapon was heavy, approximately 4.3 kilograms, fully loaded, longer than the Kar98ks that equipped 98% of German infantry. The M1 measured 110 centimeters overall, with a barrel length of 61 centimeters. By comparison, the Kar98k measured 111 centimeters with a 55 centimeter barrel, nearly identical dimensions. Yet the American rifle weighed half a kilogram more. The additional weight suggested unnecessary bulk, inefficient design. German engineers had spent decades refining the Mauser action to minimize mass while maximizing precision. Every component of the Kar98k served a specific purpose, engineered to exact specifications, manufactured to rigorous tolerances. The weapon represented the pinnacle of bolt-action design, descended from the legendary Gewehr 98 that had armed Imperial German forces in the Great War. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber operated the M1's bolt, pulling back on the charging handle located on the right side of the receiver. The mechanism moved smoothly, far too smoothly for a captured battlefield weapon that had seen combat use. German weapons required careful maintenance to achieve such effortless operation. This American rifle had been recovered from a foxhole in France, exposed to mud, rain, and the abuse of frontline service. Yet it functioned as if freshly manufactured. The bolt locked open, revealing the weapon's internal magazine. Unlike the Kar98k's 5-round internal box magazine loaded via stripper clips, the Garand employed what American technical manuals called an en-bloc clip system. 8 rounds of .30-06 Springfield ammunition were loaded into a steel clip that inserted directly into the rifle's action from above. The clip remained in the weapon during firing, ejecting automatically after the last round. To Weber's trained eye, the system appeared needlessly complex. German doctrine emphasized simplicity in infantry weapons. The Kar98k could be topped off at any time by inserting individual rounds or partial stripper clips. The American system demanded firing all 8 rounds or manually ejecting a partially full clip, wasting ammunition. In sustained combat, such inflexibility would prove tactically limiting, or so German engineering logic suggested. Oberleutnant Klaus Richter arrived at the testing bay carrying a leather briefcase containing evaluation protocols developed by the Heereswaffenamt, the Army Weapons Office. Richter had supervised weapons testing at Kummersdorf since 1941, evaluating captured Soviet, British, and American equipment according to standardized German military specifications. His reports were comprehensive, technical, and absolutely objective. They had influenced procurement decisions affecting millions of Wehrmacht soldiers. The American M1 Garand, Richter announced, opening his briefcase and extracting a thick folder. Intelligence reports claim it provides American infantry with significant firepower advantages. We will determine if this assessment has merit. The testing protocols were thorough, as German methodology demanded. Rate of fire measurements, accuracy trials at varying ranges, reliability testing under adverse conditions, component durability analysis, and detailed comparison against the Kar98ks. Every variable would be quantified, measured, documented. German precision would evaluate American simplicity. Weber selected ammunition from the supply crate, 30-06 Springfield cartridges, American military issue. The round was powerful, firing a 170-grain bullet at approximately 840 meters per second, comparable to the 7.92 by 57 mm Mauser round fired by German rifles. Both cartridges descended from early 20th century military rifle designs, optimized for ranges exceeding 500 meters. The fundamental ballistics were equivalent. If the American rifle possessed advantages, they would not stem from superior ammunition performance. Richter established the first trial protocol, rate of fire comparison. The test would measure how many aimed shots could be fired in 60 seconds, the standard German metric for infantry rifle evaluation. This measurement provided crucial data for tactical planning. Understanding how rapidly soldiers could engage targets determined infantry squad composition, fire and movement doctrine, and expected combat effectiveness. The Kar98ks had undergone this, testing countless times. German military specifications required every infantry rifle to demonstrate specific performance characteristics. The Mauser action, perfected over decades of development, represented the fastest bolt-action design ever produced. The bolt's rear locking lugs and short throw allowed skilled riflemen to operate it without removing the rifle from their shoulder. German soldiers trained extensively on the weapon, achieving proficiency that made their marksmanship legendary. Wehrmacht training doctrine included specific drills, measuring rifle handling speed. Experienced German riflemen could fire 15 aimed rounds per minute from the Kar98ks. This performance required pulling the bolt up and back, ejecting the spent cartridge, pushing the bolt forward to chamber a new round, pushing the bolt down to lock it, reacquiring the target through iron sights, aiming, and firing. The entire cycle, repeated 15 times in 60 seconds. Elite riflemen exceeded this standard. Some achieved 18 to 20 rounds per minute. The absolute maximum, documented under ideal conditions with perfectly maintained weapons, reached approximately 24 rounds per minute. But such performance demanded thousands of practice hours, perfect ammunition management, and the physical conditioning to maintain rapid bolt manipulation without degrading accuracy. Most German soldiers, adequate but not exceptional, managed 12 to 15 aimed rounds per minute in combat conditions. The mathematics told a clear story. German infantry doctrine assumed each rifleman could deliver approximately 15 effective shots per minute. Squad tactics, fire discipline, and ammunition allocation all stemmed from this fundamental calculation. Richter positioned a test target at 100 meters, standard evaluation range, a human-sized silhouette, black on white background. The trial would measure not maximum cyclic rate, which meant nothing for accuracy, but sustained aimed fire. Each shot had to strike the target to count toward the final tabulation. Weber loaded an 8-round clip into the Garand, feeling the clip lock into place with a distinctive metallic click. He settled into a prone firing position, the rifle's weight distributed comfortably across his body. The iron sights aligned naturally, the front post centering in the rear aperture. American sight design employed a different philosophy than German systems, but the fundamentals remained identical. "Begin," Richter commanded, starting his stopwatch. Weber squeezed the trigger. The Garand fired with a sharp crack, recoil punching backward into his shoulder. But something unexpected happened. The rifle's bolt cycled automatically, ejecting the spent cartridge and chambering a fresh round without any input from the shooter. Weber's finger remained on the trigger. His eye remained aligned with the sights. His body position remained undisturbed. He pulled the trigger again. Another shot. The bolt cycled again. His sight picture never wavered. He fired a third round. Fourth, fifth, sixth, seventh. The final shot ejected the empty clip with a metallic ping, locking the bolt open for reload. 8 seconds had elapsed. Weber reloaded, inserting a fresh clip. The bolt slammed forward automatically, chambering the first round. He resumed firing. 8 more rounds in 8 seconds. Another reload. 8 more rounds. The 60-second trial concluded with Weber having fired 48 aimed shots, all impacting the target silhouette. The range fell silent. Richter stared at his stopwatch, then at the target, then at the stopwatch again. 48 rounds per minute. The number violated everything German rifle doctrine assumed about infantry firepower. A single American rifleman with this weapon had just delivered more than 3 times the firepower of a German rifleman with a Kar98ks. Not 3 times the theoretical maximum, 3 times the standard performance that German tactical planning assumed for infantry combat. Weber stood, brushed dust, and spent casings from his uniform. "The weapon cycles automatically," he said, his voice carefully neutral. "The gas-operated system uses propellant gases to operate the action. The shooter needs only to pull the trigger." Richter approached the firing line, examining the target. All 48 rounds had struck within the silhouette. Accuracy had not degraded despite the rapid fire rate. The American rifle had maintained shot-to-shot precision that German doctrine assumed required pausing to work a bolt between rounds. "Again," Richter ordered. "This time, I will operate the Kar98ks simultaneously. We will compare directly." Weber returned to the prone position with the Garand. Richter settled beside him with a German rifle, loading a 5-round stripper clip into the Kar98ks magazine. Both men aligned on separate targets at 100 meters. "Begin." Weber pulled the trigger and maintained steady pressure. The Garand fired, cycled, fired, cycled, fired. Each shot required only the fractional second needed to reacquire aim after recoil. His hands never left their firing grip. His eye never broke contact with the sights. The weapon did all mechanical work required to prepare for the next shot. Beside him, Richter worked the Kar98ks with the speed of an experienced weapons evaluator. Pull bolt up and back, push forward, push down and lock, aim, fire. The Mauser action operated smoothly, its legendary bolt throw as short and efficient as human engineering could achieve. But each cycle required Richter to break his firing position, interrupt his sight picture, and manually perform the mechanical steps that the American rifle executed automatically. 60 seconds elapsed. Weber had fired 44 rounds, limited only by reload time. Richter had fired 16 rounds from the Kar98ks, performing at the upper range of standard German proficiency. The ratio was 2.7 to 1. Nearly 3 German riflemen would be required to match the firepower output of 1 American rifleman. Richter set down the Kar98ks with movements that seemed almost mechanical. His engineering background had taught him to accept data, however uncomfortable. The test results were undeniable, repeatable, scientific. The American rifle provides a sustained fire advantage of approximately 180% over the Kar98ks, Richter stated, his voice flat. 3 German and soldiers with bolt-action rifles deliver slightly less firepower than 2 American soldiers with M1 Garands. But the implications extended beyond simple arithmetic. Weber understood what Richter was calculating: squad-level tactics, platoon composition, company firepower calculations. Every aspect of German infantry doctrine assumed rough parity in individual rifleman effectiveness. Wehrmacht tactical superiority stemmed from superior training, better coordination, and battlefield experience accumulated through 5 years of continuous warfare. The assumption had been that American soldiers were individually inferior to German soldiers, less experienced, less disciplined, less capable. If they appeared effective in combat, it was through overwhelming numerical and material superiority, not through individual soldier quality. This rifle suggested a different explanation. American infantry might not be overwhelming German forces through numbers. They might be overwhelming them through firepower multipliers that German doctrine had failed to anticipate. Weber picked up the Garand again, this time examining it with the careful attention of an engineer evaluating a competitor's design. The gas system was elegantly simple. A port drilled into the barrel, near the muzzle diverted propellant, gases into a cylinder housing a piston. Gas pressure drove the piston rearward, connected to an operating rod, that rotated and retracted the bolt. Spent cartridge ejected. Magazine spring forced the next round upward. Operating rod drove the bolt forward. Fresh cartridge chambered. Bolt rotated and locked, all in approximately 1/5 of a second. The mechanical elegance impressed him. American engineers had solved a problem German engineers considered irrelevant. German doctrine emphasized precision and marksmanship. The fastest bolt-action rifle design, operated by extensively trained soldiers, delivered adequate firepower for German tactical methods. Semi-automatic operation seemed unnecessary, an expensive solution to a problem that proper training already addressed. But American philosophy had asked a different question. Instead of, how can we train soldiers to operate bolt-action rifles faster, American designers asked, how can we eliminate the need to operate bolts manually? The difference in questions produced radically different answers. Weber thought back to his years at Krupp, Works, where German engineering culture valued precision, complexity, and mathematical perfection. Every component machined to exact tolerances, every mechanism designed for optimal theoretical performance, every weapon system engineered as if each unit would be hand-fitted by skilled armorers. The American rifle represented a different philosophy. Good enough components, mass-produced by semi-skilled workers, assembled into weapons that functioned reliably without requiring perfectionism. The gas system tolerated manufacturing variances that would horrify German quality control inspectors. The receiver was investment cast, rather than precision machined. The trigger group employed stamped components instead of milled parts. Yet it worked, reliably, repeatedly. Richter began documenting the test results in his evaluation folder. Rate of fire, confirmed at 40 to 50 aimed rounds per minute for trained operators. This compared to 15 aimed rounds per minute for Kar98ks operators of equivalent skill level. Firepower advantage approximately 3 to 1. The second testing protocol evaluated accuracy at extended ranges. German military doctrine emphasized long-range marksmanship. The Kar98ks remained effective at ranges exceeding 500 meters, capable of delivering accurate fire at distances where most infantry combat never occurred. This long-range precision was considered essential, a fundamental requirement for German infantry weapons. Targets were established at 100, 200, 300, and 500 meters. Both the M1 Garand and Kar98ks would be fired at each range, measuring group size and hit probability. German specifications required 5-shot groups within a 12-centimeter circle at 100 meters. This standard ensured rifles possessed accuracy sufficient for combat effectiveness. Weber fired 5 rounds from the Garand at the 100-meter target. The group measured 9 centimeters, well within German acceptance standards. At 200 meters, the group expanded to 18 centimeters. At 300 meters, 28 centimeters. At 500 meters, 55 centimeters. Richter fired the Kar98ks through identical protocols. 100 meters, 8 centimeters. 200 meters, 17 centimeters. 300 meters, 26 centimeters. 500 meters, 50 centimeters. The accuracy was equivalent. The American rifle matched German precision standards at all tested ranges. Any firepower advantage could not be dismissed as coming at the cost of reduced accuracy. This troubled Richter more than the rate of fire data. German doctrine assumed a fundamental trade-off between rapid fire and precision. Automatic weapons like submachine guns and machine guns sacrificed accuracy for volume. Bolt-action rifles sacrificed volume for accuracy. The American M1 Garand appeared to violate this assumption, delivering both rapid-fire and rifle-level precision. The gas-operated system introduces no meaningful accuracy degradation, Richter documented. The rifle maintains shot-to-shot precision comparable to manually operated bolt-action designs. The third testing protocol examined reliability under adverse conditions. German weapons underwent rigorous environmental testing: freezing temperatures, mud immersion, sand infiltration, extended firing without maintenance. Every weapon system had to demonstrate functional reliability across the full spectrum of combat conditions German forces encountered from the Arctic Circle to North Africa. The Garand was subjected to standard German environmental protocols: frozen overnight at -20 degrees Celsius, submerged in mud, coated with sand, fired continuously until barrel heat reached operational limits. The weapon functioned normally throughout all trials. The gas system, which Weber had suspected would prove vulnerable to environmental contamination, demonstrated remarkable tolerance for fouling. Carbon buildup that would disable more delicate German mechanisms failed to interrupt the Garand's operation. The simple, robust design required minimal maintenance. The testing program extended across 5 days in mid-December 1944, each day revealing new aspects of American design philosophy that challenged German engineering assumptions. Kummersdorf's frozen ranges echoed with systematic gunfire as Weber and Richter methodically documented every measurable characteristic of the M1 Garand. On the second day, they conducted endurance trials. The Kar98k could sustain approximately 20 rounds per minute under ideal conditions, but barrel heat limited practical firing rates. Extended rapid fire risked accuracy, degradation, and potential damage to the rifle's precisely machined components. German doctrine emphasized fire discipline, controlled shooting, ammunition conservation. The Garand was fired continuously, emptying magazine after magazine as quickly as Weber could reload. After 160 rounds fired in under 4 minutes, the barrel glowed visibly in the dim winter light. The wooden handguard smoked slightly from absorbed heat. Weber paused, expecting mechanical failure. The rifle continued functioning normally. The gas system operated despite extreme barrel temperatures. Accuracy degraded slightly as metal expanded from heat, but remained within acceptable combat parameters. When the barrel cooled, precision returned to original specifications. American design accepts thermal stress that German specifications prohibit, Richter noted. The weapon tolerates abuse that would destroy a Kar98k. This observation connected to broader patterns Weber had noticed throughout testing. German rifles were engineered as precision instruments requiring careful handling. Soldiers received extensive training on proper maintenance, cleaning procedures, and handling discipline. The Kar98k performed magnificently when treated with appropriate respect. The American rifle was engineered as a tool. Soldiers could abuse it, neglect it, handle it roughly. The weapon continued functioning. This philosophical difference reflected fundamentally different assumptions about warfare. German doctrine assumed professional soldiers with extensive training. American doctrine assumed citizen soldiers with minimal preparation who needed equipment that worked despite user error. The fourth testing protocol examined field stripping and maintenance procedures. German weapons required specialized tools and technical knowledge for proper maintenance. The Kar98k could be field-stripped, but complete disassembly demanded armorer-level expertise and specific tools. This ensured weapons were maintained correctly by qualified personnel. Weber disassembled the Garand following captured. American technical manuals. The rifle separated into major components without requiring any tools beyond a cartridge rim used as a makeshift screwdriver. Trigger group, operating rod, bolt assembly, barrel, everything could be removed, cleaned, and reassembled by a soldier with basic instruction. Any American infantryman can perform complete maintenance, Weber observed. No specialized training required, no tools necessary. The design assumes soldiers are mechanically unsophisticated. Richter saw the tactical implications immediately. German maintenance doctrine required trained armorers at battalion level. Weapons needing repair were sent rearward for specialist attention. Combat units operated with whatever rifles remained functional until reinforcements arrived with replacements or repaired weapons returned from depot-level maintenance. American doctrine apparently distributed maintenance capability down to individual soldier level. Every rifleman could service his own weapon. Units maintained combat effectiveness without requiring specialized support personnel. This decentralization of capability reflected American industrial philosophy applied to military operations. The testing data accumulated. Each measurement reinforced conclusions that became increasingly difficult to dismiss as anomalies or testing errors. The American M1 Garand provided genuine, measurable, repeatable advantages over the German Kar98k in nearly every tactical parameter except weight. On December 18, 1944, Oberst Heinrich Müller arrived at Kummersdorf to review testing results. Müller commanded infantry operations at Wehrmacht High Command, responsible for tactical doctrine governing German ground forces. His presence indicated Berlin's serious interest in the evaluation findings. Richter presented the data with characteristic precision. Rate of fire advantage, 3-1. Accuracy, equivalent. Reliability, superior. Maintenance, simplified. Weight, slightly higher. Cost per unit, approximately twice German production expenses but offset by reduced training requirements and improved soldier effectiveness. Müller listened silently, his expression revealing nothing. He had commanded infantry since 1939, leading soldiers through Poland, France, the Balkans, and 3 years of brutal fighting on the Eastern Front. He understood combat effectiveness through experience that no testing program could replicate. "You're telling me," Müller said slowly, "that one American rifleman with this weapon equals 3 German riflemen with Kar98ks. "Not precisely," Richter corrected. One American rifleman delivers approximately 2.7 times the sustained firepower of one German rifleman. 3 German riflemen together deliver approximately 12% more total rounds than one American, assuming all fire simultaneously. But the American occupies one position, Müller continued, working through tactical implications. Presents one target, requires one set of supplies. The 3 Germans occupy 3 positions, present 3 targets, require 3 times the logistical support. Richter confirmed. Müller walked to the firing line, picking up the M1 Garand. He operated the action, feeling the smooth automatic cycling. His hands, calloused from years of handling military equipment, traced the weapon's lines with professional appreciation. "We knew American infantry had firepower advantages," Müller said quietly. "We attributed it to their material superiority. More artillery, more air support, more machine guns per squad. We didn't consider that their basic infantry rifle provided fundamental advantages at the individual soldier level." He turned to face Weber and Richter. "Can we produce this weapon? Reverse engineer it? Adapt it for German use?" Weber had anticipated the question. "Theoretically, yes. The design employs no revolutionary technologies. Gas-operated, semi-automatic actions have existed since before the Great War. but practical implementation would require completely restructuring German small arms production. Explain. The Garand uses investment casting for major components. We use precision machining. They use stamped parts. We use milled parts. They design for mass production by semi-skilled workers. We design for hand-fitting by trained armourers. Converting our manufacturing infrastructure would take minimum 18 months, probably longer given current industrial constraints. Müller's expression darkened. 18 months. The war might not last 18 more months. Soviet forces were already in Poland. American and British armies approached the Rhine. Germany needed weapons now, not theoretical solutions requiring years of retooling. Even if we could produce it, Richter added, we face ammunition complications. The Garand fires .30-06 Springfield. We manufacture 7.92 Mauser. Switching, cartridges would orphan existing ammunition stockpiles and create supply chain chaos. Could we redesign it for our ammunition? Possible, Weber said, but that introduces engineering challenges requiring extensive development. The gas system is calibrated for American ammunition pressures. Changing cartridges demands recalculating gas port dimensions, piston stroke length, spring tensions. Each modification risks introducing malfunctions, requiring additional testing and refinement. Müller set down the Garand with a gesture that combined respect and frustration. German engineering expertise could certainly duplicate or improve upon American designs, but Germany lacked the most crucial resource: time. The war's momentum had shifted irreversibly. Technical solutions that might have mattered in 1941 meant nothing in late 1944. Write your report, Müller ordered. Document everything. Perhaps after the war, these lessons will inform future development. The phrase, "after the war," hung in the frozen air. Everyone present understood the Reich was collapsing. The question was no longer if Germany would lose, but when and under what terms. Testing captured American rifles at Kummersdorf, while Soviet armies advanced toward Berlin, felt like archaeology studying artifacts from a future that Germany would not inhabit. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Over the following week, Weber continued analyzing the Garand's design, now motivated by professional curiosity rather than tactical necessity. The weapon represented American engineering philosophy made tangible. Every design choice reflected values alien to German technical tradition. German engineers optimized for theoretical perfection. American engineers optimized for practical effectiveness. German designs assumed skilled operators and careful maintenance. American designs assumed unskilled operators and rough handling. German manufacturing emphasized quality and precision. American manufacturing emphasized quantity and adequacy. Neither philosophy was inherently superior. Both produced effective weapons suited to their respective military cultures, but in total warfare requiring millions of rifles distributed to hastily trained conscripts fighting across multiple continents, American philosophy delivered better results. Weber examined captured American production statistics. Between 1937 and 1945, American factories had manufactured more than 4 million M1 Garands. Springfield Armory alone produced over 3 million. Winchester added another 500,000. Production peaked in January 1944 at nearly 4,000 rifles daily from Springfield alone. German production of the Kar98ks totaled approximately 14 million units between 1935 and 1945. Impressive numbers, but achieved through extensive mobilization of Germany's entire industrial base. Multiple contractors, diverted resources, increasingly simplified manufacturing as raw material shortages intensified. American production of semi-automatic rifles equaled roughly 30% of German bolt-action production. Yet those 4 million Garands provided American infantry with firepower superiority that German numbers could not overcome. Quality multiplied by force multiplier advantages defeated quantity. The mathematics were brutal. An American infantry division with 12,000 riflemen armed with Garands delivered equivalent rifle firepower to a German division with 36,000 riflemen armed with Kar98ks. 3 German divisions matched 1 American division in basic infantry firepower, before considering American advantages in artillery, armor, and air support. This explained Wehrmacht commanders' consistent reports of being overwhelmed by American firepower. German forces weren't being overwhelmed by numbers. They were being overwhelmed by force multiplication through superior equipment distributed to adequately trained soldiers. Richter's final evaluation report documented these conclusions with characteristic German thoroughness. 42 pages of technical analysis, supported by measurement data, photographic documentation, and detailed comparison charts. The report would circulate through Wehrmacht High Command, reach senior officers responsible for tactical doctrine, and ultimately disappear into archives as Germany's military situation deteriorated beyond salvation. On December 23, 1944, testing concluded. The 6 captured M1 Garands were catalogued, documented, and placed in storage, along with thousands of other captured weapons that Kummersdorf had evaluated throughout the war. Soviet forces were 70 kilometers away and advancing. American bombers occasionally appeared overhead despite winter weather. The testing facility would be evacuated within weeks. Weber wrote his personal conclusions in a private journal that night, observations he could not include in official reports. The American rifle represented more than engineering achievement. It embodied philosophical differences between German and American approaches to modern warfare. Germany had entered the war believing superior training, tactical doctrine, and individual soldier quality would overcome material disadvantages. Wehrmacht forces initially validated this belief, defeating numerically superior opponents through skill and coordination. But the Americans had systematically negated German advantages through industrial production and equipment design that multiplied average soldier effectiveness. The M1 Garand was just one example. American forces employed similar philosophy across all equipment categories. Sherman tanks were individually inferior to German Tigers, but Americans produced 50 Shermans for every Tiger. American artillery lacked German precision, but Americans fired 10 shells for every German round. American aircraft weren't as advanced as German jets, but Americans flew 100 missions for every German sortie. Quantity had its own quality. More importantly, adequate quality produced in overwhelming quantity defeated superior quality produced in limited numbers. This was America's essential advantage: industrial capacity protected by oceans from enemy disruption, producing sufficient material to arm forces with equipment good enough to win. German engineering culture viewed good enough as an insult. German weapons were engineered to exacting specifications, manufactured to rigorous tolerances, designed to be the absolute best possible. This perfectionism produced magnificent weapons in insufficient quantities. The Kar98k was arguably the finest bolt-action rifle ever manufactured, but finest bolt-action rifle could not compete with adequate semi-automatic rifle produced in millions. Weber closed his journal and looked out across Kummersdorf's testing ranges, now dark under winter night. Somewhere beyond the darkness, American soldiers carried M1 Garands through France, Belgium, approaching the German border. Each of those soldiers could outshoot 3 German riflemen. Together, they formed an unstoppable tide of firepower that German tactical brilliance could no longer contain. The next morning, Weber received new orders. Kummersdorf would prioritize evaluation of captured Soviet weapons. American testing was complete. The data existed, documented with German precision, but the conclusions arrived too late to matter for Germany's war effort. Years later, after the war ended and Germany rebuilt under Allied occupation, Weber would encounter former Wehrmacht officers at engineering conferences. They discussed the testing program, the conclusions, the lessons learned too late. The M1 Garand entered, their conversations as a symbol of American industrial philosophy defeating German engineering perfectionism. Some maintained that, given time, German engineers could have designed superior semi-automatic rifles. Perhaps. But time was the resource Germany lacked. Americans had begun developing the Garand in the 1920s, adopted it in 1936, refined it through years of production, and equipped their entire military by 1941. Germans were still debating theoretical improvements to bolt-action rifles when American semi-automatic rifles were already winning battles. The Sturmgewehr 44 represented Germany's attempt to leapfrog American semi-automatic rifle technology with fully automatic assault rifles. Over 400,000 were produced in the war's final year, but 400,000 could not replace 14 million Kar98ks already in service. The SAIT G44 arrived too late, in too few numbers, to influence outcomes that were already determined. This pattern repeated across German weapons development. Tiger tanks, superior to anything Allies fielded, produced in numbers insufficient to matter. Jet aircraft generations ahead of Allied designs, appearing when Allied air superiority was already absolute. V-2 rockets representing revolutionary missile technology, consuming resources that conventional weapons would have employed more effectively. German engineering genius was undeniable, but genius applied to wrong problems at wrong times produces magnificent irrelevance. The Americans asked simpler questions and implemented practical answers. Their M1 Garand was not the theoretical best possible infantry rifle. It was a rifle good enough to win, produced in quantities sufficient to arm millions of soldiers, designed to function reliably in the hands of inadequately trained users. This philosophy won wars. In late April 1945, Soviet forces overran Kummersdorf. The testing facility was systematically looted, documentation seized, equipment removed. The 6 M1 Garands that Weber and Richter had evaluated disappeared into Soviet arsenals, along with countless other weapons captured during Kummersdorf's decade as Germany's premier testing facility. Weber survived the war, eventually finding work with West German industrial firms rebuilding the nation's manufacturing capacity. He occasionally lectured at technical universities on weapons design philosophy, always returning to lessons learned evaluating the American M1 Garand in December 1944. "We German engineers," he would tell students, believed perfection mattered most. The Americans taught us that adequacy in vast quantities defeats perfection in limited supply. This is perhaps the most important engineering lesson of the 20th century. Richter's evaluation report survived in duplicate copies recovered from Wehrmacht archives after the war. Military historians studied the document, recognizing it as one of the most comprehensive German analyses of American weapons technology. The conclusions were prescient, the data meticulous, the implications clear, but the report changed nothing because it arrived when Germany's military fate was already sealed. The M1 Garand continued serving American forces through the Korean War, where it again demonstrated firepower superiority against opponents armed with bolt-action rifles. Soviet Mosin Nagants and Chinese-type Zhongjung rifles faced the same disadvantages German Kar98ks had encountered. American infantry consistently outshot their opponents through technological advantages that training and tactics could not overcome. The rifle was eventually replaced by the M14 in 1957, which adapted Garand's gas-operated system to accept detachable 20-round magazines and selective fire capability. The M14 lasted only 7 years before being replaced by the M16, but Garand's fundamental design, principles gas-operated, semi-automatic, optimized for rapid fire, remained standard for military rifles worldwide. Modern assault rifles from AK-47 seconds to M4S employ variations of operating systems that trace lineage to John Garand's innovations. The semi-automatic action became universal. Bolt-action rifles, no matter how perfectly engineered, could not compete with weapons that eliminated manual cycling between shots. Germany eventually adopted semi-automatic and automatic rifles in its post-war military forces. The G3 battle rifle and later the G36 assault rifle armed Bundeswehr soldiers with weapons philosophically descended from the American M1 Garand. German engineers had learned the lessons Weber documented at Kummersdorf in 1944. The Kar98k remains a masterpiece of bolt-action design, still admired by collectors and firearms enthusiasts for its smooth action, superb accuracy, and elegant engineering. Museums display the rifle with appropriate reverence for its place in firearms history. But history judges weapons by their battlefield effectiveness, not their engineering elegance. The M1 Garand changed infantry combat more profoundly than any rifle since the introduction of breech-loading firearms. It proved that semi-automatic operation provided decisive tactical advantages. It demonstrated that adequate engineering produced in quantity defeats perfect engineering produced in limited numbers. Most importantly, it showed that asking the right question matters more than providing the perfect answer to the wrong question. German engineers asked, "How can we build the best possible bolt-action rifle?" American engineers asked, "How can we eliminate the need for bolt-action operation?" The difference in questions produced different answers. The difference in answers influenced battle outcomes. The difference in outcomes determined which nation won the Second World War. Weber's journal entry from December 23, 1944, concluded with a passage that captured his professional assessment. "We tested the American M1 Garand and discovered it was not a better rifle than our Kar98k. It was a different rifle, designed to answer different questions, optimized for different priorities." In retrospect, the Americans asked better questions. Their rifle provides 3 times our firepower with equivalent accuracy. No amount of German training or tactical superiority can overcome such fundamental materiel disadvantage. We built the finest bolt-action rifle in the world. The Americans built a rifle that made bolt actions obsolete. History will record which approach mattered more. The testing program at Kummersdorf in December 1944 represented one of countless moments when German forces confronted Allied technological and industrial superiority. Each encounter revealed the same fundamental truth. Germany was fighting 20th century industrial warfare with 19th century assumptions about quality versus quantity. The Kar98k remained an excellent weapon throughout its service life. German soldiers used it effectively until the war's final days. But excellence could not overcome the mathematics of firepower ratios. When one American rifleman could match 3 German riflemen, numerical parity meant German defeat. American forces advancing into Germany in early 1945 carried M1 Garands with justified confidence. They knew their rifles provided meaningful advantages over German weapons. They knew that in firefights, volume of accurate fire mattered more than theoretical precision at ranges where combat rarely occurred. They knew their equipment, while perhaps not perfect by engineering standards, was good enough to win. And it was. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.